Hey y'all, so we're gonna continue with our notes from last class. So this is the same notes packet as when we started to talk about logarithms and exponentials as inverses. So this is on the back of the first page. It is halfway down. You guys have this graph, and it would be a great idea if you labeled, okay? Okay, you can't see that, but domain is, let me not do pink. Domain is how far side to side our graph goes. Alright, so in the case of a logarithmic function, it's going to have a vertical asymptote. It's not going to go it's not going to go left and right forever, basically, the way that exponentials do. For range, it is going to go up and down forever. So the range is going to be all real numbers instead. We have our y-intercept, x-intercept. It's always going to have an x-intercept. But we have that asymptote. So instead of an exponential, our asymptote goes side to side. It's horizontal. Our logarithmic has a vertical asymptote. So it's going straight up and down. Then, so you don't touch or pass the asymptote. Y-intercept, it will depend on where the asymptote is. So if it's right here on the y-axis, it doesn't cross the y-axis, then there would be no y-intercept. But if it moves to the left, or if it flips or whatever, it could cross the y-intercept and that would result, or cross the y-axis and that would result in a y-intercept. So please make sure that you're jotting some of this down so you have it to reference. But what we're going to talk about before we look at the attributes is how we get a logarithmic function by solving an exponential. So we are given our original function. I'm kind of just going over what we went over in class. So we've got our original function, and we're trying to find an inverse. Now this is an exponential function because it has an exponent. It does not have the word log in it. This is not logarithmic. Let's keep these in mind. The first thing I'm going to do is not even really a step. It's just something I like to do. So I'm going to write y instead of f of x. My first official step is to switch x and y. So instead of y equals, I've got x equals 3 to the x plus 7. Oh, no. 3 to the y plus 7. My bad, guys. My next step is to get y alone, or solve for y, in other words. Right now when I'm looking at y, I see a plus 7, and then I see this 3 out here outside of the parentheses at the bottom of this exponent, the base of my exponential. The thing that is furthest away from y is not the plus 7, it is this 3. Now since it's an exponential, and I want to get rid of the exponential, I have to do the opposite of an exponential. And the opposite of an exponential is a logarithmic. And this is where we bring back the formula that we talked about last class. B to the x equals a. And then we've got, I'm done, it's too late. Then we can rewrite that as log with a base of b, and then a equals x. So since I'm given it in this form, I want to rewrite it in this form. So I'm going to start out with writing log, and then my base, my number on the bottom, is going to be this 3. My a is going to be the number that was on the other side of the equal sign from the base, right? So it'll be x. So I'm going to put it in parentheses. And then that equals whatever my exponent was. My exponent is here. That is y plus 7. All right, now y is still not alone here. Okay, it still has a plus 7 next to it, so I'm going to get rid of that plus 7 by subtracting 7 on both sides. And that minus 7 stays outside of the parentheses at the end. And this is my function. Okay, so this is my inverse. Oh my god, I can't spell. Inverse. Okay, now what we're going to do with this is we are going to graph both the original and the inverse. So we're going to graph them. And then what we're going to do is we're going to find these attributes for each of them. Our domain, our range, our x-intercept, our y-intercept, and our asymptote. So I'm going to go to Desmos to do this. So we've got 3 to the x plus 7. And then we've got log is 3 of x and then a minus 7 outside of the parentheses. So I'm going to scroll out a little bit and then zoom in more over here. Alright, so we'll start with, and I'll kind of make my own little chart, if you will. So for the exponential, we'll start with that first. Right. We're going to have our exponential, our logarithmic, we're going to start with our domain. Right, so for our exponential, the domain, range, x-intercept, y-intercept, and then the asymptote. Alright, so for my exponential, which is our original one that we started with, I'm looking at domain. So I like to pick a point and just drag it. And since domain is x values, I'm looking at the first number on the graph, seeing how far left and right it goes. So this just keeps going. So it goes to negative infinity. And I see that if I drag it to the right, it is also not looking like it is going to stop. So for my domain, I can write negative infinity to infinity, or you can write all real numbers. For the range, I look at how far down it goes. I notice that the y value is stopping at 0. So we can say it goes down to 0. It does not touch or cross 0, but it gets very, very close. Then I can go back up, and it does not look like it's stopping. So I can write 0 to infinity. You could also write y is greater than 0. That's an option, right? For my x-intercept, well, my graph does not cross my x-axis, so it does not have an x-intercept. Right, my y-intercept, I'm going to have to zoom out a bit, spoiler alert. So it is 0, 2,187. Then my asymptote, we already talked about, it stops. It does not cross or touch at 0. Y equals 0, right? Because that's my second number that is 0, and that's my y value. So my asymptote is y equals 0. Now that should be a review because we took a quiz over this whole thing, but we're also going to look at the log function. Now, Desmos does a really bad job with log because it just like doesn't act like some of it exists. So they don't act like it goes past a certain point. It definitely does. Okay, so don't say it doesn't. We're going to start out talking about domain though. So we're going to pick a point, drag it, and ta-da. It does not go past x is 0, but it is going to go to the right forever. So I can write this as 0 to infinity for my domain, or I could write it as x is greater than 0, since domain is talking about x values, and it starts at 0 and goes to the right. That would be greater than. Then I'm looking at my range. Even though it stops at undefined, your range is not undefined. You have eyes. Take a look at the graph. It keeps going. All right, so it goes down forever, and then it goes up. It just keeps going up, and it's going to keep going up. All right, it does not stop going up. So my range is what is all real numbers. X-intercept, we've got one. It is 2187, 0. Now, as for the y-intercept, it does not touch or cross the y-intercept. See, the closer I zoom in, the it never touches. So, it's a none for the y-intercept. And then for the asymptote, I look and see where it stops. I see what's the number it stops at, and then what kind of value it is. Now, it stops at the number 0. And since 0 is the first value in this point, that is my x value. So my asymptote for my logarithmic is x equals 0. Now, something that I hope you notice is that because with exponentials, x and y switch, in these attributes, the attributes that are associated with x values, like domain and x-intercept, switch with the attributes that are associated with y, like the range and y-intercept. So here, instead of the domain being all real numbers, for my logarithmic, the range is all real numbers. Instead of range being y is greater than 0, it switches. So for logarithmic, now my domain is x is greater than 0. Instead of my y-intercept being none, my x-intercept being none, my y-intercept is none for logarithmic. And notice that these numbers are the same. They just switched what they were a part of from y-intercept to x-intercept. And instead of an asymptote being y equals 0, it is x equals 0. So there's a lot of switching going on here. Okay, that's pretty much the only example. No, JK, we're going to do one more, finding an inverse, but we're not going to do another attributes one because this pretty much covers all of it. And then I also go over it in the video kind of describing the delta math. So we'll do one more problem going over how to find an inverse, just in case you get something as heinous as this problem. Also because we wanted to practice going from a log to an exponential, so going the other way. First thing I like to do, y equals 1/3 log base 2 of x plus 3 plus 2. Then I like to switch x and y. I need to write smaller. Okay, first step done. My second step is to solve for y. So the furthest thing away from y, I've got a plus 3, I've got the log, I have a 1/3 outside of the log, and then I have a plus 2. The furthest thing away is that plus 2, so I'm going to get rid of that. Opposite of plus 2 is minus 2, of course. Then I've got the plus 3, I have log base 2, but outside of the log, I've got that 1/3. So I want to get rid of that next. Now, the way I get rid of any fraction is I multiply the fraction, the whole fraction, by the number that is in the bottom of the fraction. Okay, so I'm going to multiply this by 3. I'm going to multiply this side by 3. Here, this cancels out. Here, this just says this 3 times x minus 2. Alright, now the next thing I have to get rid of is the log. Now, the only way I can get rid of log is by doing its opposite, and the opposite is an exponential. So yet again, we bring up this formula. Oh, why did I do that? It's supposed to be with B, and then A, and X. And then an equal sign in between that. So, I'm given a log, I want to write an exponential. So I'm going to want to write it like in this format. So I start out with my base. So my base is 2. My exponent is going to be found on the other side of the equal sign from the log. So this is my exponent. Alright, and then my A is going to be this. So it should equal A. Bro, I wanted to write it in pink. 5 plus 3. Now it's not quite done because y is not completely alone. So the last thing I have to do is subtract 3 from both sides to make my y be alone. And my final answer is that my inverse is y equals 2 to the 3 times x minus 2, and then a minus 3 over here. And this is my inverse of my original function. Okay. Well, with that being said, from this point, you can begin on the delta math. It is 2 questions. I would highly recommend watching the video where I work through an example so you guys can kind of get a feel for what you need to do on the assignment, right? Let me know if you have any questions, and good luck.